Hello, today we are doing questions from iDefects. iDefects question actually in the MCQ paper you will see we are getting at least one question. So it's always better to be prepared with this question. Alright, before moving into the questions, we are quickly going through theory points. We have short sightedness and long sightedness. In short sightedness, actually near point is visible, infinity is not visible. In long sightedness, infinity is visible, near point is not visible. So basically we need to find the focal length or the power of the lens, right? So but basically we need to apply lens formula here. So let's take an example and let's find the focal length of it, right? So here let's say for a person actually he won't be able to see beyond 2 meters. That means from 25 to 2 meters is visible, right? So infinity is not visible. So basically what we do is assume we are making an image of infinity at 2 meters. So let's apply our lens formula. 1 over v minus 1 over u equals 1 over f. Let's apply the values. So we are creating an image of infinity at 2 meters, right? So v, it has to be 2 meters because that's the image distance. It's 2 meters. And our object is at infinity. So it's 1 over infinity f. That is what we need to find, right? Then when it comes to simplification, 1 over infinity, of course, that is 0. So 1 over 2 meters equals 1 over f. F is 2 meters. Basically, that is what we are supposed to do in the questions. So let's go through with couple of questions, and it's always better to try it first and then discuss this later. Right, let's do the questions now. Alright students, moving into the very first question. If you are able to do this question, that is great. That means you know theories. Right, let's get into the question now. A man is wearing glasses of power plus 2D, can read clearly a book placed at a distance 40 centimeter, right? From the eye, the power of lens required so that he can read at 25 centimeter from the eye is, right? So first thing we need to remember is that this 40 centimeter is not the real near point, right? So we need to identify the real near point. So what we have to do is we have to apply lens formula 1 over v minus 1 over u equals 1 over f. So let's put the values. V, of course, that is the real near point. In many cases actually the image distance is the real near point or real far point. So minus 1 over u is the object distance 40, and f actually we need to find. Power is plus 2d, so then by applying p equals 1 over f, so 2 equals, it's actually minus 1 over f, so f becomes half 0.5 meters, so in centimeters it's 50 centimeters. So let's apply that value here. Minus, remember minus 1 over 50. So v equals 1 over 40 minus 1 over 50. So common denominator is 200. Actually simplify, we have to simplify it. So let's simplify. 1 over v equals 1 over 40 minus 1 over 50. Let's take the common denominator 200. So 5 minus 4, it's 1. So 1 over v equals 1 over 200. We get 200, v equals 200 centimeters. So this is the real near point, 200 centimeters. Right. Then we need to see the objects clearly at 25 centimeters. So we need to, what we have to do is we have to create image of this object at 200 centimeters. So again let's apply lens formula. From that we can get the answer. So let's apply 1 over v minus 1 over u equals 1 over f for this new scenario, right? So v, of course, now new v is 25 centimeters, is this 200 centimeters. So 1 over 200 minus 1 over 25 equals 1 over f. So common denominator, let's take 200. So 1 minus 7. So we are getting 1 over f equals 8. So we are getting f equals 200 over 7. Remember this in centimeters. So let's convert into meters. So f equals 2 over 7 meters. And power is the reciprocal of this value. And of course this is minus. So power becomes 7 over 2, and of course positive minus positive. So equals plus 3.5 D. That is our answer. You can see it's this 3.5. Alright, moving into the second question. This question actually a bit of a distracting question, because this point here 23 millimeters. Let's read the question anyway. The least distance of distinction of a defected eye is 50 centimeters, having a diameter of the eyeball 23 millimeters. To see an object 25 centimeters away from the eye clearly, what additional power should be supplied by the spectacle? So they are asking us the additional power, not the eye lens power or anything. So if only eye lens power or something is required, actually then only we need this 23 millimeter value. Otherwise we can apply our very normal method we did. So what's the normal method we did? So basically we need to identify the real near point. So real near point is 50 centimeters. That's the real point. The least distance of distinction of defected eye is 50 centimeters. So we need to see the object clearly at 25 centimeters. So what we have to do is we have to create an image of this object at 50 centimeters. So basically when applying equations, we need the near point, the image distance 1 over v minus 1 over u equals 1 over f. So image distance, it has to be 50 minus 1 over 25 equals 1 over f. So let's take the common denominator 50. 1 minus 2 equals 1 over f. So you can see it's minus 1 over 50 equals 1 over f. So you can get f equals 50 centimeters, right? So then we convert it into meters. So it's 0.5 meters. Basically power equals minus 1 over f. So minus 1 over 0.5, it's minus into minus cancel off. So plus 2t. So answer is the first one. That is the required power, right? So this is actually another question model that we can find in papers. Right, if you could do the question, that is great. Let's get into the question now. A certain person has a defective eye. The distance between the eye lens and the retina. So here actually the difference in this question is they are talking about the eye lens and the retina also, right? So if this is the eye lens, this is the retina, and they are talking about the distance between them is 0.025 meters, right? Let's write it down, 0.025 meters. But the power of lens resting eye means it's looking at the infinity, right? Remember that, resting eye. So it's 45 diopters, 45D. What should be the type of the power corrective lens he should wear in order to see the distance object, right? Remember that when looking at the distance object, actually eye at rest, and it acquires the maximum focal length as 0.025. This is the maximum focal length actually for an eye when at rest. So we can assume then f is equal to 0.025 meters. So let's find the power of it. Power equals minus 1 over f. So 1 over 0.025 f. Simplification, 1 over 25 into 10 to the power minus 3. Then I would say 1000 goes up, 1000 divided by 25, it's 40 diopters. So this is the requirement, and this is actually 45 diopters. That means it's powerful, much more powerful than the required energy. So required power is 40 diopters, and the current power is actually 40 diopters, 45 diopters. So we need to, what we need to do, we need to decrease the power. So for that we need to connect it with a concave lens, not a convex lens, because convex lens will improve or increase the value. So we need to use a concave lens of FD. So what happens is 45D minus 5D that becomes 42. So answer is the fifth one, concave 5D. Hello students, there are lots of questions in the playlist. Just go through with the playlist and find the questions that are suitable to you and try the questions, and you will find something new for sure.